Good morning everyone. Welcome to the course Network Theory. This is Dr. Satyavani Bandela, Assistant Professor, SR University, Warangal, Telangana. And today we are going to discuss series and parallel resistance network in lesson number 5. So we already finished in previous class lesson number 1 with introduction to electrical network, and we discussed in lecture 1 different types of classification of electrical elements, active passive elements, example with their units, and in lecture 2 we discussed Ohm's law and basic electrical power equation and energy equation. So let me revise that Ohm's law. According to Ohm's law, provided at constant temperature, current through the conductor is directly proportional to applied voltage, and finally derived formula we have written V equals to IR. Then next power equation, electrical power equation. Let me write that power equation. And power is a product of voltage and current we have taken, and the next energy is a product of power and time. So these things we have discussed in lecture number 2, Ohm's law with electric power and electric energy. Then in lecture number 3, so we discussed Kirchhoff's current law, and according to Kirchhoff's current law, it is algebraic sum of current at node equals to 0. So what is meant by node? Node is a junction or point at which two or more elements connected together. So here this is a junction or node. Here we have to apply Kirchhoff's current law. At node, algebraic sum of current at node equals to 0. That is Kirchhoff's current law. Even we solved a few problems in that lecture number 3. And 4, Kirchhoff's voltage law. According to Kirchhoff's voltage law, the statement algebraic sum of voltages in closed circuit equals to 0. So where it is in closed circuit, you may have the voltage sources and elements like resistor, inductor, capacitor. We have taken example with voltage and resistance, and like this we have written the voltage based on the polarity and based on the direction of current through the resistance, it is minus IR, and this is the voltage drop across resistance. Like we solved few problems on Kirchhoff's voltage law in lecture number 4. Now in this lecture number 5 we are going to discuss series and parallel resistor networks. Now we will see those circuits. So first of all we will see electrical circuit. So electrical circuits are the basic building blocks of all electrical systems. So thus understanding the current flow means based on the elements, how the elements are connected in the electrical network. So we have to estimate what is the current and what is the voltage across among all the elements which are connected in the network. Means before that we should know how the elements are connected. So basically there are two different types of connections. They are series and parallel circuit. Now here let me underline this. This is basic circuit connections are series and parallel circuits, and these connections affect how devices operate in a system, and the concepts are widely used in real life applications like home wiring and electrical equipment. How all the elements like bulb, fan and everything, how all the elements are connected, whether they are in series or parallel, and if they are in series, and what is the parameter, whether current, how the current is distributed, how the voltage is distributed among series and parallel network, that we will see by taking one example circuit. First see the series combination of circuit. Now here we will see series network, how to connect the elements in series. Here I am taking one simple example with one voltage source, and here I am connecting 3 resistors in series. One resistance 1, resistance 2 and resistance 3. Okay. if the elements are connected like this in a closed circuit, then these elements are the combination, or this type of connection is said to be series network. Okay, and here is the voltage source V, R1, R2, R3. All these four elements, one is a voltage source, this is active element, and these three are passive elements. All these three elements are connected in series. Okay, so then what is the property if the elements are connected in series? How to identify? For example, if the current delivered by this voltage source is I, then whatever the current which is flowing through R1 is same as through R2 and R3. Okay, again back to the voltage source, means among all the elements current will be the common, same current is flowing throughout the network. So that's why the series network is nothing but the property of series network is same current, common current will flow throughout the network. Okay, same current throughout the network. But coming to the voltage, for example, if I take voltage drop across this R1 resistance, so where this voltage drop across R1 resistance V1 is known as, according to Ohm's law, current through R1 is I and drop resistance value is R1, and voltage drop across R2, let us take V2. Here I am representing voltage across R2, V2, and how to write this V2? V2 is I into R2, I into R2. Similarly, what is V3? It is I into R3. Okay. Now here I am applying Kirchhoff's voltage law. So algebraic sum of voltages in closed circuit equals to 0, and this is the voltage source capital V, and the polarities are minus and plus. Now here I am writing apply Kirchhoff's voltage law in this circuit. The first element is voltage source V, and the second element is resistance, and the direction of current is towards the direction of current is in clockwise. So the drop across the voltage resistance is taken as minus, and what is voltage drop across R1? It is I into R1. The next element, voltage drop across R2, already we discussed in previous class while discussing that KVL. So I into R2 here, the next element I into R3, voltage across R3. So these are the four elements and voltage across all four elements according to KVL, algebraic sum of voltages in closed circuit equals to 0. Okay, here I am taking like this. Then finally the source voltage equals to I into R1 plus I into R2 plus I into R3. So this can be written as the total voltage, source voltage V equals to, if I take current as common, I into R1 plus R2 plus R3. Okay. Then this can be written as total voltage V equals to total current delivered by the voltage source into R equivalent. Means what is R equivalent? So where R equivalent is sum of resistors R1, R2 and R3. Okay. So this is the equivalent resistance of three elements. Means finally if we talk about the series network, so these are connected in series. What is the property? Same current. When all the elements are connected in series, the property is same current but voltage division takes place. Is it right? And from that we will get the equivalent resistance of this network is sum of all the resistors. Okay, so we have taken only 3 resistors, that's why what is the equivalent of this resistor? R1 plus R2 plus R3. Okay, so this is the example of series connection. Okay, Now we will take one circuit diagram with resistance element and we will find R equivalent. Let us take one simple network with resistor element with voltage source, simple voltage source. Here I am taking 10 volt and the polarity minus plus, okay, and the resistance value here I am taking 3 ohm and here it is 2 ohm, okay. Now how these two resistors are connected? They are in series, okay. Now here I am applying KVL. This is total source voltage 10 minus voltage across 3 ohm is I into 3 and voltage across 2 ohm is minus I into 2 equals to 0. The next 10 equals to I into 3 plus 2. If I write these two, current voltage drop across resistance right side, this is your equivalent resistor 3 plus 2, and from this you will get current magnitude I equals to 10 divided by 3 plus 2 means 5, and how much? 2 ampere current. How much current is flowing through all the elements? 2 ampere current. So we got current 2 ampere, and from here itself you can take the equivalent resistance of the network. What is equivalent? If two elements are connected in series, R1 plus R2. What is R1? 3. What is R2? 2. How much it is? 5 ohm resistance. Okay. Now what is voltage drop across 3 ohm resistance? It is I into 3, where I is 2 ampere and 3 it is 6 volts. Voltage across 3 ohm is 6. Now what is voltage across 2 ohm resistance? It is I into 2. So the current magnitude got 2 ampere and the resistance of this R2 is 2 and 2 into 2 4 volt. Now look at this. Here how much voltage we applied? Here the source voltage is 10. Then what is the voltage drop across 6 ohm? That is 3 ohms, it is 6 volt. See here, voltage across 3 ohm resistance we got 6 volt, and voltage across 2 it is 4 volt. Voltage across 2 ohm is 4 volt. Now look at this, 10 voltage is divided into 2 parts, okay, and whatever the current which is flowing through 3 ohm resistance, 2 ampere current, and same current is flowing through 2 ohms. So hence in series circuit, when elements are connected in series, then the property is same current but voltage division takes place. Voltage division, okay. So total 10 voltage is divided into 6 volt and 4 volt among two elements. So this is about series circuit. Now we will see parallel circuit, how to connect elements in parallel. Now here we will see the parallel circuit, how to make parallel circuit with the 3 elements, one voltage source. Here I am taking one voltage source and one resistance R1 and the second resistance R2. Okay. So if the elements are connected like this, so this is your voltage source V and resistance R1 and resistance R2. So voltage, this first terminal of R1 is connected to positive and the second terminal of R1 is connected to negative terminal of source voltage. Means I can write voltage across R1 is the source voltage V, okay, and the voltage across R2, here I am writing voltage across R2. So the terminal, first terminal of R2 is also connected to plus and this second terminal is connected to minus. So voltage across R2 is also source voltage V. Means when two elements are connected, when elements are connected in parallel, voltage across all the elements parallel circuit is same. Okay, same voltage will exist among parallel elements. Then what about current? Now let us take current delivered by this voltage source. Here I am taking capital I. Okay. Now this is the junction where voltage R1 and R2 are connected together. Clear? Now this current, total current is divided into two parts, and current through R1 I1 and current through R2 remaining current, that is I2. Means the total current I is divided into two parts, that is I1 plus I2. So how you will get this? According to Kirchhoff's current law. So this current is towards node, it is plus, and these two currents are leaving node, that's why minus I1 minus I2 equals to 0. So means I can write capital I equals to I1 plus I2 from Kirchhoff's current law. Now look at this. Voltage across R1. See, voltage across R1, that is R1 equals to, according to Ohm's law, this is, I can write I1 into R1, right? I1 into R1, and voltage across R2 in terms of current, I2 into R2. Clear? And where VR1 is same as the source voltage and VR2 is also same source voltage V. Clear? Now here I am writing the current I1 from this equation. From this equation I can write current I1 equals to V by R1. V by R1 plus I2 current can be written as V by R2 from this equation. So let me write this. I2 equals to V by R2. Here I am writing I2 equals to V by R2. Okay. Now this is the total current. So what is total current? It is total voltage divided by total equivalent resistance. Right. Now V numerator V will get cancelled. If I write again this equation, 1 by R equivalent equals to 1 by R1 plus 1 by R2, where R equivalent is the equivalent resistance of R1 and R2. Means when two elements are connected in parallel, if R1 and R2 are connected in parallel, 1 by R equivalent equals to 1 by R1 plus 1 by R2. Example, if I take three resistors in parallel, let us take 1, R1, R2 and R3. If these three resistors are connected in parallel, I am writing R1, R2 and R3. What is R equivalent? It is not R equivalent. 1 by R equivalent can be written as 1 by R1 plus 1 by R2 plus 1 by R3. If I connect one voltage source like this, then the total current I is divided into three parts, I1, I2 and I3. So I equals to I1 plus I2 plus I3. So like this we have to proceed for parallel circuit. Okay. So this is about parallel. Then how to get what is the final statement of parallel network? See, the voltage is, here I am writing for parallel circuit, parallel network, the voltage will be the same, and but current division takes place. Okay, so current division takes place. Okay, the opposite, in series same current, voltage division. In parallel, same voltage but current division takes place. So, this is about parallel network. Clear? Now, we will see if any network contains a series and parallel, how to find out its equivalent resistance. Here I am taking example circuit. See, I am taking one network with series and parallel element. Now, see, two elements are connected in series and I am connecting other two elements in parallel with, let us take only R equivalent. We will find first R equivalent. So, with respect to this, what is an R equivalent? Okay. So, the value here, let me write this number: 3 ohm resistance, 2 ohm resistance, 10 ohm resistance, 10 ohm resistance. Okay. So, for simplicity here I am telling parallel, because parallel resistance is if two elements are connected in parallel, instead of writing 1 by R equivalent, directly we can take R equivalent equals to R1 R2 by R1 plus R2. If two are connected in parallel, R1 R2 are in parallel. Now, if three elements are connected in parallel, 1, 2, 3, R3, then what is R equivalent? We have to write like this: R1 R2 R3 divided by R1 R2 plus R2 R3 plus R3 R1. If 4, how to write R equivalent? R1 R2 R3 R4 divided by R1 R2 R3 plus R2 R3 R4 plus R3 R4 R1 plus R4 R1 R2. So, like this you have to proceed. If n number of resistors are connected in parallel, you have to remember this equation. Instead of taking 1 by R equivalent, you can take R equivalent like this. You can remember the equation. Now, in this network, first of all, identify the elements, how they are connected. Now, see here I am, this are 3 ohm resistance and 2 ohm resistors are connected in series. Okay. So, when two elements are connected in series, what is equivalent? R1 plus R2. Now, this is A terminal. Let us take, this is B terminal and the bottom point is C terminal. Okay. Now, from point A to point B, then here 3 and 2 are connected in series, means what is equivalent? 5. 3 plus 2, it is 5. Now, between B and C, this 10 ohm resistance and 10 ohm resistance both are in parallel. When two resistors are connected in parallel, okay, what is R equivalent? Now, let me represent this with like this with a different color. Now, when these two are connected in parallel, R equivalent is R1 R2, means 10 into 10 by R1 plus R2, 10 plus 10. If I do this, 100 divided by 20, it is 5 ohm. Okay. Now, where should I connect this 5 ohm equivalent resistor? Across B and C point. So, C point is here, this is C point. In between B and C, what is R equivalent? 5. Okay. So, after this network, you have to draw like this. Okay. Now, in this network, from the terminal A, now 5 and 5 comes in series. So finally I can write a single resistor between A, first point, this is the first terminal, and C is the last terminal. I am combining these two elements together, R1 plus R2, that is 5 plus 5 equals to 10. Now this is 10 ohm resistance is your equivalent value. Okay. So like this you have to calculate if elements are connected in series and parallel. We will take one more example circuit. Now look at this network, and here is the voltage source V with 24 volt, and R1 is 7 ohm resistor, R2 is 10 ohm resistor, R3 6, and R4 4 ohm resistor. So first of all try to identify series and parallel. First here this current is dividing into two parts, but there is no resistor in parallel, but at right side if I take the current here, it is I, and this is I1 and this is I2. So whatever the current which is flowing through R3, same current is flowing through R4, means these two resistors are connected in series. What is series equivalent? 6 plus 4, R1 plus R2. Okay. So here it is represented, these two are in series because same current. Now equivalent resistance 10 ohm, 10 ohm, 6 plus 4 10. But where should I connect that 10 ohm? Let us represent terminal A and B. Okay. So now 24, as it is 24, after that 7 ohm is there and 7 ohm is there, but here I am 10 ohm resistance between A and B. Let us draw 10 ohm as it is, but together 6 4 will become 10, another 10 also comes in between A and B terminal. Here this is between A and B terminal, between A and B terminal another 10 ohm resistance comes. So like this, after this is the reduced network. Now in this network there is no series element, but there is a parallel circuit, or these two 10 ohm resistance and 10 ohm resistor. These two are in parallel. So when two elements are connected in parallel, what is R equivalent? R1 R2 by R1 plus R2. When 10 and 10 are connected in parallel, 10 into 10 by 10 plus 10, how much it is? 5 ohm. And that 5 ohm is connected between A and B. Here I am taking A and B. When I combine these two, it becomes single resistance, and that magnitude is 5. So after this is the reduced network. You have to draw like this. Then next, now when you look at this network, now it looks like all the elements, it is like all the elements are in parallel. Means the same current, whatever the current divided by this voltage source, the same current is flowing through the 7 and 5. Now what is R equivalent here? Now 7 and 5 are in series. R equivalent equals to 7 plus 5, which is 12 ohm. Okay. R equivalent is 12 and the voltage source is 24. Then what is the current delivered by this voltage source? According to Ohm's law, I equals to here V by R, 24 divided by 12, it is 2 ampere current. So the total current here, it is 2 ampere. This is 2 ampere. If you want, we can see the current magnitudes also, because let me take different color. Here what is the current delivered by this voltage is 2 ampere. Now here it is 2 ampere, 2 ampere, 2 ampere. But there is, this is 10 ohm resistance, 10 ohm resistance. When two equal resistors are connected in parallel, it shares equal amount of current. When 2 ampere current is coming from here, means 10 ohm resistance takes 1 ampere and another 10 ohm resistance take 1 ampere. Okay. If we are getting, let us take 100 ampere. Here 50 ampere, 50 ampere means here I am taking example when two equal resistors are connected in parallel. Let me write 10 ohm resistance and 10 ohm resistance. If I am getting 50 ampere current, then what is the current through this? 25, and what is the current? 25. So it shares equal amount of current, 25 ampere, 25 ampere. If it is 10 ampere, 5 ampere, 5 ampere. Okay. So like this it shares equal amount of current. So we have to solve any network based on their connections. If they are in series, add the resistors. If two elements are in parallel, take R equivalent R1 R2 by R1 plus R2, or else 1 by R equivalent equals to 1 by R1 plus 1 by R2, so on, based on number of elements which are in parallel. So this is about a series and parallel circuit. I hope it is so this is one more example circuit, and in this network first you have to solve this parallel network where R equivalent equals to R1, R2, R3, 10 into 5 into 2 divided by 10 into 5 plus 5 into 2 plus 2 into 10. So like you find out R equivalent, and that equivalent resistance comes in series with 15, and then finally you can calculate current, or here in this case current is provided, here it is asked what is the voltage. Okay, you please try to solve this problem and verify your result with this solution. Okay, so with this we finished in today's lecture series parallel circuit. Okay, so in next class we will go with another topic in lesson number 6. Thank you.